Okay, let's go ahead and just do one more little lecture here. We do a few final touches on that code we were working on last time. And as a quick reminder, what we're doing is we were looking at the Lab 7, which is that astro crash, where we had previously looked at how to detect when bullets collided with falling asteroid, and that meant asteroids. That meant checking for collision between each asteroid against every bullet, and every bullet against every asteroid. And we used a nested loop for that. We went through each asteroid and checked it against each bullet, and then we marked them for removal if they were colliding by putting them in another list. We only added them to that other list if they weren't already in the list. And then after the fact, we went through the list of ones to be removed, and we removed them from the main list. And so we use that nested loop thing like this. We kind of elaborated on that last time, but here's what the screen looked like. So what I want to do today is I want to add a few final touches to that code we worked on last time. I'm going to add a few things to it. One thing I want to add is I want to add kind of a ground like we have here. I want to add a star field in the background. I want to have some of this on-screen font output that at least has a number of bullets and number of asteroids. And I want to look at how do we add this amount of time survived, how many seconds we have left. So I'm going to add some of that stuff. So if you follow along with what we have here, everything except the population and how to get the game to end, you'll have done, and you'll also have a star field added to the background, which makes it look better. So let's go back to that code where we were last time and take a quick look at where we had finished up. Let me get that code opened here. And let me bring that up on the screen so you guys can see what I'm doing. So let me switch this over. Okay, so here's the code from last time. Oops. Here's the code from last time. And to give you an idea where we finished up, we had our bullet. We created our bullet objects. We created our asteroid objects. We created our player ship object, or classes for each of those. And then we have this distance function that we created, which we're using to do our collision check. Now down here, we actually created our player ship object instance. We started at 400, 550, so 400 across, 550 down, so almost to the bottom, but not quite. We created our empty lists. We just stuck 10 asteroids in that list to start with. Let's go ahead and change this and make it how it should be for the actual game. So in the actual lab, it says that every time through the main loop, there should be a 1 in 100 chance of creating a new asteroid. So let's undo what I just did there. So notice the way we add an asteroid is like that there. So we want to have a 1 in 100 chance of doing that. So here in my main loop, what I'm going to do is here, I'm going to say if random dot rand int, and let's do 1 to 100. If that ever equals 1, that's a 1 in 100 chance. Then we just add an asteroid to our asteroid list. So that's our 1 in 100 chance right there. Basically, we're like rolling a 100-sided die, and if it comes up 1, we go ahead and add the asteroid. So that takes care of that part. So now that will work like it says in the lab sheet. Now let's go ahead and run this, make sure we look at, oops, I need to delete out the rest of that loop before we move that code. All right, so let's take a quick look at what that does when it runs. And there it is, and there are the asteroids falling, and we had already made them different sizes and slightly different colors. So you can see them kind of raining down. They're coming down in such a way that I'm not going to be able to shoot all of them. And so we're going to have times when we don't get a lot, and we're going to have other times where we get clusters of them that come down. Okay, so there's what we have so far. So let's add a ground to the bottom, and let's add a star field. So let's start with the ground. That's pretty easy. So I'm going to actually make a function for that. And to draw the ground, we're just going to do pygame.draw.rectangle. And the way the rectangle works is we put the display surface, we give it a color. Let's make it some shade of green. So 0 red. Let's do 100 green. Let's do no blue. So there's a shade of green. If you remember, the way the rectangle works is we give it a tuple that has 4 parts. The first is the x and y coordinate. So the x is going to be 0. The y is going to be, I don't know, let's try 570. And now we give it a width. Our width is going to be 800. And our height is going to be, well, let's see, we're at 570. So to get to 600, we have to add 30. And we're going to make it solid and filled in. So we made that function. Now let's go ahead and call that. Now the question is, where do we want to call that? Well, we don't want it to be over the top of the ship. So we're probably going to want to draw the ground right here. So let's just call the function that we made. So we call the draw ground function. And there's our nice green ground at the bottom. And if we wanted to change the size of it or change the color, we certainly can do that. But I think this looks okay. Now let's add a star field. So to draw the star field, I'm going to need to have a star list, and I'm going to go ahead and create an object class for that. I'm going to call this star. And this is going to work a lot like the other objects. So I'm just going to copy this bullet because a star is really just a dot. The only difference with the stars is they're not going to move. And for the size, let's get rid of size for now. We'll pass in an X. We're going to pass in a Y. The color of these, actually, let's not even give them a color. So you just have an X and a Y. They're just going to be like little dots. But what I'm going to do down here for the color is I'm going to make them scintillate a little bit. So I'm going to make them change colors slightly so they look like they flicker. So here I'm going to say this is a local variable, color equal random.randint. And I'm going to make this a pretty high number. So I'm going to do like 200 to 255 for the red. And actually, let me make this green and blue. So this is going to be a pretty bright color, but notice it's going to pick a different color each time. So we're going to have some color variation here. I'm going to put that there. And I'm also going to have some size variation here as well. So I'm going to make a local variable for that also. I'm going to say size equal random.randint. And we're just drawing circles, but we'll make them from a pixel range 1 to 3. Okay, so there's my star class. Now I need to make a list of those. So down here, I'm going to make a list of those, kind of like we did earlier with these. I'm going to say star list equal, make it empty. And now I'm going to make and fill this in. So for I in range. And let's do a range of, I don't know, let's add 100 stars to start with. We can add more later or less. So let's do star list.append. And what are we going to append to that list? A star object, a star object instance. And to that star object instance, we would pass an X and a Y here. Now, to further simplify this star, since they're always going to be random, let's go back up to that class and change the way that that works. So here, rather than even passing anything into this, let's just make it so it picks a random place for it anyway. So let's do random.randint 0 to 799 and random.randint 0 to 599. Okay, so when we create a star, it has a random place. It remembers that place so they don't jump around on the screen. It's always in the same place. Okay, so now we have our list of 100 stars. Now we just need to, in our code, go through and draw all of them. Now, the draw order might matter here in some way. So, for example, notice that we're moving and drawing the asteroids up here. moving and drawing the bullets down here. We probably want the stars to be behind that. So one of the things I would do is do that drawing first. Now, realistically, what I would do is if I were writing this code, I would keep all the rendering actually down here. Which means that I'm going to rearrange this code that we wrote before a little bit. I'm going to move the clear screen down here. Right there. That also means that rather than drawing and or moving and drawing the asteroids and the bullets up here, I'm going to take the drawing of these out. So this is just going to move them. This is going to check for collision. This is going to get rid of any of them that we need to get rid of. And now down here is where I'm going to say for bullet in bullet list, bullet dot draw. So we'll draw everything down here. And then let's draw the asteroids as well. For asteroid in asteroid list, asteroid dot draw. And notice that this is much cleaner because now all of the rendering is down here. But now we also want to draw the stars. Now the stars should probably be behind right after we clear the screen. So the bullets are in front of the stars, the asteroids in front of the stars, because the stars, if we drew them later, they'd be over the top of the asteroids and they wouldn't look like stars anymore. So we want to draw those here. So for star in star list, and let's get our indentation level correct here, star dot draw. All right, so now we clear the screen, we draw the stars, we draw the bullets, we draw the asteroids, we call the draw ground function, and then we call draw the player ship, and then we update to the display. Let's run it and see what we got. Okay, and there are our stars. Notice they are scintillating. They're changing color slightly. They're changing their size slightly, so they look like they're flickering. And now we have something that looks like quite a bit more like an actual game. The asteroids circles right now, but we're not going to spend a lot of time putting graphics on there just yet. But when you get to the point where you add graphics to this, this becomes suddenly and music and sound effects, explosions and things like that. This suddenly starts to seem like a real game. But the stars definitely help. Okay, so switching back for just a second to here, we added the star field. We actually added the ground, which I didn't have on the list here. Now let's add some of that on-screen font output. So let's add the thing that shows how many asteroids there are. I'll leave it up to you to figure out how to add the number of bullets, but I'm going to at least add, well, we'll pick one. We'll do one or the other. Okay, so what we're going to do is we're going to go back and create the font, and we're going to at least add the number of bullets, and we'll add that time survived down in the corner. But it'll be up to you to add the last few things to the game logic. All right, so let's go back to the code and look at how to do that. So the first thing I'm going to need, if I'm going to use a font, is I'm going to need to have a font that gets loaded. So up here, before the main loop, I'm going to do pygame.font. Now, if you remember the font functions, there are two of them. There's font, which creates a font object from a font file, and then there's sysfont, which uses built-in fonts. And the way sysfont works is we give it a name, we give it a size, and then we can say whether we want it bold or italicized. And in our case, we don't care if it's bold or italicized, so we're just going to leave that alone. So, but we do have to give it a name or a size. So I'm going to pick Arial, which is a font that's available, and I'm going to pick a size of, I don't know, let's pick 30 and see how that looks. We can always change the size later. Now what this returns is a font object. So I'm going to say font 1. And one of the things that I'll do in my code is I'll often sometimes name them based on what font it was that was loaded. So font underscore Arial underscore 30. Or I could run that all together, font Arial 30. And now I have that font. So now to use that font, I need to take that font object and use that to render text, which is going to create a new surface, and then we need to blit that to the screen. So let's go down here in my main code. So down here is where we're rendering stuff. So we probably want the heads-up display to be on top of all of the other stuff, on top of the screen. So I'm going to put it down here. So here, draw HUD, the heads-up display. So I'm going to say, now, font Arial 30 dot render. And as a quick reminder of how the font functions work for rendering the fonts in Pygame. Oh, I'm doing code here without you being able to see. Hold on one second here. Switch it back over. So as a quick reminder, what I did here, let me go back up. Before the main loop started, I made this font Arial 30. I basically used pygame.font.sysfont to load the Arial font, size 30, and then I made a variable to keep that font object in. And then down here in my code, in my rendering portion where I moved stuff around, after I do all of the other game logic, I'm going to draw the HUD last before I update the display. So font Arial 30.render. And when I render something, we want to have the text here that we're going to render first. So what I'm going to write here is, let's just put the number of bullets on here. Bullets. Now, since this takes a string, we're going to have to give it a string, so we're going to have to say plus. And now here, we want the length of the bullet list. But that is going to be a number, and we can't add a number to a string unless we convert it, so we need to convert that to a string. Like that. And if you remember how the font render works, you'll notice that it says it takes at least 3 arguments and only 1 was given. So let's go back and look at that again. So font render. And you'll notice what it takes is the text, and then whether we want it to be anti-aliased, and then what color we want it to be. So what we need to do here is say whether we want it to be anti-aliased. And anti-aliased fonts look better, but they take a little more CPU time. But I'm going to go ahead and say true. And now we want to have what color we want it to be. So the color we want this to be, I'm just going to make it like a, let's make it like a yellow color. So 255, 255, 0. So now when we render this, this doesn't show it on the screen yet. This just renders it to a surface. So I'm going to say font surf equal that. And now we have to blit this onto that surface onto the screen. So to blit that on the screen, display surface.blit. Display surface is where we're blitting it to. The thing we want to blit from is the font surface. And the destination is the location we want it to be. I'm just going to put it at 0, 0. We can move it around here in a little bit. Now let's see what we get. So there it is, the number of bullets. And as we fire, you'll notice the number of bullets goes up and then it goes back down again. And a couple things about that font, the way I have it right now, is I would like a space between that colon and that the number. And I also think the font is a little bit large, so let's make it a little bit smaller. And let's also move it down and to the right a little bit. So notice that once we create this, we can change it pretty easily. So I'm going to come up here, and instead of font Arial 30, let's go and make this like 24. And I'm going to change the name of the font object just to match that, 24. And then let's come down here where we're doing the rendering of that thing. And now we're going to use the font Arial 24. Remember, I also said I wanted a space there, so I'm going to put a space there. And then we said we want to move this over and down a little bit, so let's move it over to 10, 10, so it moves it 10 over and 10 down, so it's not all the way up in that left corner. Okay, that looks a little nicer to me. And notice you have complete flexibility over the color and the placement and the what's actually getting printed, but now we have that bullet count. Here you can't quite see that. Let me move this over. So now you see that in the upper left-hand corner in our heads-up display. Okay, so to figure out how to add the asteroids, same concept. You could reuse that same font object. Just do that another step, another 2 lines like we did down here. Like we did here. You'd have font surf equal, you could reuse that same font. asteroids colon length of asteroid list, whatever color we want it, and then we could blit it. We just have to blit it in a different location so it's not over the top of the one we already have. All right, last thing we're going to do is the time. How do we have this thing so time's going up? And there's a number of ways to do that, but the one I'm going to use is we're going to import time, or there's a pygame.time function built in that gives you the number of milliseconds that since pygame was initialized. But I'm going to use the time module because we've used that before for time.sleep and other things. But essentially, how do we get an elapsed time? Well, what we want to do is say we're going to make a variable and capture the start time of the application. And there's a function called time.time that gives us the number of seconds passed since January 1st, 1970 GMT. Now that's a really large number, but what we're going to do down here in our code is before I go to render that elapsed time on the screen, I'm going to, which I'm going to do down here, and I'm actually going to reuse the same surface. So let's do this font serp equal, we reuse Arial 24. Here we'll say time survived. Now we don't want the length of the bullet list. We want to have elapsed time. But we don't have elapsed time right now. We have survived time. So we need to calculate that. So a good way to calculate that is to say elapsed time is equal to the current time, so time.time gives the time right now, minus the start time. So in other words, what time it is now minus when we started, that's how many seconds have passed since then. And we're going to need to add one more thing to this, which we'll see in a second. But now when we go to blit this, and notice I can reuse this font surface because after I blit it, I'm done with it. So you can reuse that variable for this other surface now. If you wanted to, you could make this like the bullet font surface and this the time font surface. But there's no reason to waste that memory. We can just reuse that variable. So down here, we need to put this in a different place. So notice on the original screen, that showed up in, on the original program, that showed up in kind of the bottom right. So let's put it down there. So the bottom right is going to be somewhere around, we'll just put this around like 700, and we'll say like 560 or something like that. We'll see what that looks like, and then we can move it around later. Let's run that and see what it looks like. Okay, so notice there it is down there, but it's too far over to the right. We need to move it to the left some to be able to see that. So let's move that to the left. So to move it to the left, we're just going to change this part, the X, rather than 700. Let's try 550. And again, we can put this wherever we want. Okay, that looks pretty good, but I probably want to move it down some so it's not halfway off the ground, or make the ground a little bit taller. Or maybe a combination of both. So let's move it down a little bit. So right now it's at 550, 560. Let's move it down to 570. Let's put it at 575 and see what that looks like. And then there's another thing that I don't like about it. Okay, that looks better. It's right at the bottom. One thing I don't like is all these decimal points here. It's not relevant to the gameplay. So maybe we just want to cut it off at an integer. Well, we know how to take a floating point number and turn it into an integer. Essentially what we need to do here is just make an int of that elapsed time, or we could actually do it up here and say let's take the int of that whole thing and stick that into that variable. Now when we run that, we have our elapsed time, which is a nice whole number of seconds. And now we have something, so minus the only things that are missing from this now as a full working game would be the, at least as described, would be the count of the asteroids being displayed at the top. Pretty easy to do. And then the population going down, and then the game over screen after you die. So I'll leave those things for you to figure out. But notice that this is pretty close where we have it right now. So if you followed along, then you should be at the point where you can get the rest of this done. And make sure you understand the code. Don't just like type in what I did. Make sure you understand what it's doing and why it's doing it. If you don't, rewatch the lecture again. If you still don't, watch it again. And that's one of the advantages of having this stuff on videos. You can watch it as many times as you need to understand it. And then if you need some bonus points, remember to look at that lab sheet, because there's a chance for changing those out for graphics. There's a chance for adding sound. There's a chance for adding people that get squished and adding little craters at the bottom. I do want to make the ground a little bit taller, and this is the advantage of writing the code in kind of a nice, clean way like this. Notice the main loop is in this, because we used object-oriented programming, is actually pretty clean. That we basically start up here at the top of the loop, inside the loop. We initialize all the stuff that we need ahead of time, making these empty lists, adding the 100 stars. I think I want a few more stars for this, make it look a little better. But then you'll notice going down through the rest of this code, we get the keyboard input, respond to the keyboard input down here. We then go through and move all the asteroids, any of them that are off the screen. We tag them to be removed by adding them to these removal lists. Same thing with bullets. We then go through all the bullets and all the asteroids in this nested list. If they're too close together, they're so close together they're colliding, then if the bullet already hasn't been tagged for removal, we add it to the list. If the asteroid hasn't been tagged for removal, we add it to its list. And then we just go through and remove any of them that need removed from either of those two, from the asteroid list, bullet list. And now we're up to rendering. And for the rendering, we clear the screen to black. And if I were writing this code, I'm going to make one more change here. I'm going to say, just like we had draw ground, I'm going to make a clear screen function because that makes this look cleaner. We clear the screen, we draw the stars, we draw the bullets, we draw the asteroids, we draw the ground, we draw the player ship, and then we put the font information up on the screen. And then we update to display. So let me add that function up at the top for clear screen. Super easy to do. Def. Oops. Clear screen. And we just make that one call. Now notice this is a one-for-one replacement, so we haven't reduced the amount of code. We actually added a little bit of code, but that makes it so, again, one of the nice things about functions is they allow for abstraction. So now rather than having this weird mysterious ds.fill 000, we have in our main code clear screen. We know exactly what it's doing. So we run that. We now have our 150 stars, and maybe I want the stars to have a little bit more of a bluish tinge to them. Maybe a slightly wider range of sizes too. Let's go 1 to 4 here. And let's make the colors of these 210, 220, and then let's make this start at 220. So these will be more blue than so they're a little more blue than they are red and green. And I was actually happier with the size being a little bit smaller. It's a little bit too flickery now. They're a little bit distracting. So let's go back to 3 there. All right, that looks pretty nice. I'm pretty happy with that. Okay, so minus a little bit of game logic, we now have that full working version of that game. And if you think the stars are a little bit too bright, remember you can always make them a little more gray to make them a little less distracting, because what's determining how bright they are these colors we're giving them. So 200, 210, maybe we knock this down a little bit, and let's take 50 off of this and make this like 150 to 160. Or let's do 170. And let's do the same thing on this one. 150 to 170. And if we do that, now they're going to be way more blue. I actually kind of like that. That looks good now. So they still look whitish, but they have a cooler blue kind of coloration to them. And if we wanted to change the number of stars, that's easy to do. Now, one final thing here that I'd suggest is things like that, where it's a number of stars. Rather than hard coding it like I did here to say 150, what I like to do in my code is to say something like this. Now, if I make an all caps thing like that in my code, that indicates that's something that's like a variable that is like a parameter for how the game runs. So up here, I could say like num stars, and then I can set that at the top. And I like to define those all in one section rather than having them spread out. So if it's something that's controlling the game, like maybe the size of the screen, the height and width of the thing, you might have that be for how quickly the asteroids spawn, or the cooldown time for the gun. That lets you set up this set of variables that you can tweak to change the gameplay rather than having them spread out all over the code. And I believe we did have that cooldown in here as well. So let's change that also and put that at the top. So let's find where we were using that cooldown amount. Okay, gun cooldown equal. There it is, hard coded to 30. So I'm going to call this gun cooldown frames. So now that variable there becomes part of the something I could tweak for the game play. So up here, gun cooldown frames equal 30. And if I wanted it to be able to fire more slowly, I could increase this number. If I wanted it to fire more quickly, I could decrease that number. Let's make it fire a little less frequently so it's harder to just spam. But it makes it nice to edit that code now because we have those constants all kind of stored in one place at the top of the code. And we can edit that. And maybe this is too many stars. It's a little bit distracting. But we're going to leave it like this for now. And last thing I said I was going to do is make that ground a little taller. So to do that, because we used functions, we just go to the draw ground section of the code. And right here, that is the height. That's the starting point. So let's start this at maybe 560 and make this 40. So we just made it 10 units taller. And that looks a little nicer. And now let's move this font where that's being positioned up just a little bit and then over to the right just a little bit. So here's where we're drawing that. Here's where we're positioning it. So we wanted to move it up a little bit and over to the right. So over to the right would be maybe move this to 560. Or let's move it over to 600 and see what that looks like. And then move it up a little bit. So 570. Let's take a look at what that looks like. Okay, that looks a little nicer. Okay, so let's go back to the presentation just for a second here. Okay, so we did what we set out to do here. We added the star field. We added the on-screen font output for a couple of things. Notice you would have to add the population. You'd have to add the number of asteroids. This version didn't even have the star field, but the star field adds a lot to it. And then you can focus on those bonus points, the number of craters, or adding the craters, adding the sounds, changing these out for graphics to get those bonus points. But we did all the stuff we set out to do. So that's all for now. Go ahead and try to finish Lab 7 and be ready for the programming part of the final exam next week. Everybody stay safe. And this is really the last lecture we're going to have this semester. Some of you I will see again. Some of you probably won't, unfortunately. But I really wished more of you would have watched these lectures. This is good stuff that we covered here, and the more you learn about this, the more fun it is. Again, it's like being able to do a wizard. Just that I enjoyed just throwing together that little bit of code over these last 2 lectures to make that game, which is something that I've written before. But it's fun. It's enjoyable to add things and say, okay, well, now let's add spaceships that fly across and shoot at the player. Let's add change the graphic of the spaceship so it looks like it's spinning. Let's add different weapons that some of them spread and some of them have lasers and some go up and explode. Being able to do all that kind of stuff is super fun to play with. It's like the Legos of your mind, where you aren't stuck with the certain bricks to stick together. You can build your own bricks by making functions or objects and then putting them together however you want to make whatever kind of game you want. You want to make a game with really cool, interesting stuff in it, and physics and stuff that collides together, and you want to add things that shoot and then dungeons to explore and things that talk to you and things that run away from you, and ants that forage and gather things and store them back in their nest, and they gain things on their own. All of that stuff you can do. Whatever you dream up, you can build if you learn a little bit of this programming stuff and a little bit about the it really is kind of like the magic of ideas. And the coolest part to me is you can take those ideas out of your head. You can put that idea in the computer, and it does that without. It's like taking part of your brain and letting it run outside of your head and seeing what it does. And it takes a little bit of work to learn. And I'm sorry that this semester has been remote. I think that a lot of you would have done a little bit better if you were locked in a room with me and had to sit there and listen to what I was saying. I think a lot of you need to attain a little bit higher maturity level and force yourself to watch the videos and take the stuff seriously, because I could tell by the number of views on the videos and the number of downloads of the lecture slides. A lot of people just blowing it off and not watching it. And I feel a little bit sorry for you that you had to have your first freshman year, first semester experience be remote like it was, especially coming out of high school where things were a little more structured into something less structured. But if you're still interested in this stuff, I'd encourage you not to give up. This is really cool, really fun stuff. The program here at the university is top 10 in the country, and it is there for a reason. The people that come out of this degree are wizards and rock stars for the most part, and I want to help you be a wizard and a rock star too. So if you feel like you didn't live up to your own expectations, I'd encourage you to go back and watch the videos from this class, because the stuff we did in here is going to be really powerful and really useful for what you're going to do with the rest of your academic career and your actual career in the industry. But you're going to need to learn to be more proactive and learn to be more responsible for your own education from here on out. Those of you who've watched the videos and have done well on the tests and have done all your labs, I look forward to seeing you guys again. And everybody keep in touch. And sorry this semester was kind of a shit show as far as COVID-19 is concerned. It's kind of the world we live in right now, which is unfortunate. But I've enjoyed having you guys in class. Hopefully I'll see you guys in future classes if you stick with the degree, or I'll see you in maybe 1802, where you get to learn a lot more cool stuff about programming. Take what we've learned this semester and build your own game from that, your own project. That's kind of your freshman year capstone project, where you get to put that in your portfolio, make something polished, make something that's your idea rather than my ideas, and make it do whatever you want it to do. And if not, then I'll see you in systems programming. I might see you in automata. I'll see you in concurrency. I'll see you guys later in the degree. And I look forward to sharing more of what I know to be powerful spells and wizardly things with you in the future. If you have any questions on anything, let me know, and be ready for that programming part of the final exam. Best way to get ready for that, watch these lectures, do the labs, understand the labs, play around with stuff. And one of the things over break I'd encourage you to do is play with programming. While it's easy to get on Reddit or get on Discord and just chat with friends and goof around, there's a really huge reward for just playing with programming and making stuff and building things and writing code. And it's an enjoyable thing. It's like painting a picture from the ideas in your mind. It's a very creative thing to do. And you guys have time in your lives now over break that you could actually spend some time playing with that. All right, that's it. Everybody stay safe, stay healthy, keep your family safe, wear a mask, social distance. COVID has made a lot of things different this year. Hopefully next year will be quite a bit different. See you guys soon.